Okay, section 2.2, video 2. So what we're going to talk about in this part of the video is what's called piecewise functions. And then we're also going to talk about this thing which is called the difference quotient. Okay, so first of all, piecewise functions. What it means is if you look at a graph, it literally means that there's two different functions that actually make up the entire graph of whatever function it is that we're talking about. So you could have a function that looks like this, and that certainly is a function. And then you could have another function that picks up where this one started, but maybe it's at a different spot, maybe it's down here, and then does that. So what you can see is the red and green are two different functions, right? One is a horizontal line, the other one is a slanted line. They're actually two different things, but they actually create one entire function. Let me go ahead and put a little solid dot right there. And they are functions because they pass the vertical line test. They don't overlap each other. None of that stuff happens. These two functions may connect. They may not connect. This one does not connect. Sometimes they will connect. I believe there's one in your book that looks like this. It's the same type of thing, and then it does that. So these are actually still piecewise functions. It's two different pieces that create one function. It is not one smooth curve that's all just one function. So these are what are called piecewise functions. So what we're going to do is we're going to talk about how you evaluate a piecewise function, how you would read that. So a piecewise function, when you write it, is going to look something like this. F of x equals, and then they use the brace notation to indicate that you've got multiple pieces making up this function. Well, on the one on the left here in red, and I'm going to make these values up. I don't know exactly what this is. Maybe this is 2, just making it up. Well, that would be f of x equals 2. But it's only going to equal 2 up to this x value, whatever x value that is. We'll call this x value 3. So it's only going to equal 2 if x is less than 3. But it does include the 3 because if you look at that, the solid dot is on the red part. So it's if x is less than or equal to 3, you're going to have that red piece. And then, and again, I'm just completely making this up, maybe the equation of this slanted green line here is, I don't know, 2x minus 7. I'm just completely making that up off the top of my head. Well, that means that my piecewise function is going to be the function 2x minus 7 if, and you should be able to see that from 3 to the right, or from 3 to infinity, is where the green line is going to exist. So that would be x is greater than 3. And it does not include the 3 because the 3 is included with the red one, which is where the dot is. There's an open circle on the green one. Okay, and that's the general idea of what we're looking at with a piecewise function. There could be multiple pieces. There could be 3 pieces, 4 pieces, 7 pieces. We're only going to deal with a couple, but there could be multiple pieces. It just depends on how many pieces make up your function. So what we want to be able to do is we want to be able to look at a given function and evaluate it. So we'll do a couple of quick examples of that. So let's say that we're given this function. So we're given c of t equals, here's our piecewise function, 20 if 0 is less than or equal to t, which is less than or equal to 60. We'll talk about how to read that. Or it's 20 plus 0.4 times t minus 60 if t is greater than 60. So what we want to do is we want to evaluate c of 30. What that means is I want to know what the function's value is when t is 30. This is your t value. Well, I'm going to look up here, and I'm going to say, wait a minute, t is 30. 30 is in between 0 and 60. So that means I'm going to use this top portion right here. Well, there's nothing to plug anything into. It's just telling me that if t is between 0 and 60, the value is 20. So this is simply 20. It's whatever that function's value is. If I, however, wanted to evaluate c of 100, well, 100 is a value which is greater than 60. So I'm going to look at this piece. This one does have something for me to plug into. So I'm going to plug 100 in for t into that one and then figure out its value. So that would be 20 plus 0.4 times plugging 100 in for t, and then we evaluate it. I'm going to do a bunch of mental math here. Let's see, that's going to be 100 minus 60 is 40 times 0.4 would be 1.6 plus 20. I should get 21.6, I believe, if I did that correctly. No, that's not right. 40 times 0.4 is 16, not 1.6. 16 plus 20. Yeah, that's right. 16 plus 20 is 36. So that's what it would mean to evaluate c of 100. It would actually give you 36. So the biggest thing is you just have to know which piece you're going to look at and which piece you're going to evaluate at. All right, so let's do one that's just a little bit more straightforward. All right, so we're going to be given f of x is the piecewise function, which is defined to be x plus 2 if x is less than or equal to 1, and f of x is 4 if x is greater than 1. All right, so let's go ahead and evaluate f of 0. No, f of 0, f of 1, and f of 4. So f of 0, well, 0 is in this category because 0 is less than 1. So I'm going to plug 0 into the top equation and evaluate it, and that's just going to give us 2. So f of 0 is 2. It has nothing to do with the bottom piece because 0 is not in the bottom piece. F of 1. That's a good one because the top equation says x is less than or equal to 1. The bottom equation says x is greater than 1. Well, less than or equal to 1 includes the 1, so again I'm going to use this top equation for f of 1. So plugging 1 in gives us 3. And then f of 4, 4 is bigger than 1, so x is bigger than 1. The x value is bigger than 1, so we'll use this. I have nothing to plug 4 into, so it's just going to be whatever that value is, which is 4. And that's evaluating the piecewise functions. All right, I'm going to show you a graph. Well, we're not actually going to use this. This is just kind of a good thing for you to be able to see. There's this other thing which is called a step function. It is also a piecewise function. It's actually very commonly used every day. If you think about going to, if you ever driven downtown Baltimore or DC or something, and you have to park in a parking garage, a lot of times the parking garages will say, you know, $4 for the first 20 minutes, and then it's an extra $1 every minute after that. Well, that's what these things are. This is called a step function. Whoops, didn't mean to write on that. And it's piecewise. What you should be able to see is there's a whole bunch of different pieces here. There's this piece, this piece, this piece, this piece, and they're all disconnected, which is why it's definitely piecewise. All these different things are pieces, and if you kind of look at the shape of it, it looks like a step. What it means is between x is 0 and 1, not including the 1, the y value is 0. Between x is 1 and 2, not including the 2, the y value is 1. Between x is 2 and 3, not including the 3, the y value is 2, and so on. Anyway, that's called a step function. It is a graph of a piecewise function. It's actually called the greatest integer function. We don't need to worry about that. Just wanted to kind of show you that that is out there, and that is a graph of something that could be a piecewise function. You don't have to worry about that. Just an interesting side thing on there. Okay. Last thing that we have to talk about is this thing which is called the difference quotient. Okay, math people are not extremely creative when they call things names because they pretty much just label them what they are. It is called the difference quotient, difference meaning subtraction, quotient meaning division. So literally the difference quotient is this. It is f of x plus h minus f of x over h. Now this has a lot of applications in higher level math. For right now, we just need to be able to figure out how to evaluate one of these things. Algebraically, these things can get very messy. So you have to be really careful with your simplification. I'll go through one example here, and then hopefully you guys will be able to practice this on the homework that I give you guys. It does take a long time. I will try not to give you more than just a couple, but you can expect to see one of these on an exam at one point in time. So the difference quotient says I need to evaluate something which is f of x plus h minus f of x over h. Well, f of x is just going to be whatever function is given to us. So let's say our function, f of x, is given to us as 2x squared minus x plus 3. If I want to find the difference quotient of this, I need to find f of x plus h and f of x. Fortunately, h is just h. It's going to stay there. Well, f of x, that's the easy part. That's this. So I've already got that part. I could fill that in right now if I wanted to. I do, however, need to find f of x plus h. F of x plus h, remember, is taking this x plus h, this stuff, and I'm going to plug all that in for all of my x's here. So let's do that. 2 parentheses, something squared, minus parentheses, plus 3. What I am filling into those parentheses is x plus h. This is where it gets a little messy. In order for me to simplify this, I'm going to need to expand all of this stuff. I'm going to need to foil this guy, distribute the negative into here, because I got to get rid of all the parentheses to simplify it. So let me see what happens here. 2 stays there. I got to foil this. So this is x plus h squared. If you remember your square double square, it's easy to do. If not, you write out x plus h times x plus h. Do go through the FOIL process and then see what you get. Square double square would be the first one squared, which is x squared. Multiplying x times h, you get xh. If you double that, you would have 2 xh's. And then squaring the last one is h squared. Okay. On the second piece, I'm just distributing the negative sign into here. So I'm going to get negative x minus h, and then plus 3. The last thing I need to do to simplify this is to distribute the 2. So the 2 gets distributed here, here, and here. So we're going to have 2x squared plus 4xh plus 2h squared minus x minus h plus 3. That is very lengthy, and it gets a little messy. That is f of x plus h. Well, that's what I needed to fill into this top. I needed f of x plus h right here. I now have it. I already had f of x. We're just got to plug everything in now and simplify. So it's going to be quite a long fraction. F of x plus h goes in first, so I'm going to recopy that. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Then I have to subtract, and you can put all that in parentheses if you want to make it a little cleaner. I have to subtract f of x. This is f of x. Keep it in a parentheses, because if you don't do that and you subtract, you're going to end up messing up your signs. So 2x squared minus x plus 3, all that stuff over h. So this is what I'm going to tell you. If we have done this correctly, everything that does not have an h in it hopefully should start to simplify and subtract out on top. Let's see if that's what happens. So I'm going to rewrite this. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now I'm distributing the negative into here, here, and here. So that's going to give me minus 2x squared plus x minus 3 all over h. Let's see if what I said was going to happen happens. If you look at the top, it's a whole bunch of stuff. I'm going to combine like terms. I got a 2x squared out in front, but I have a negative 2x squared off to the right. So 2x squared minus 2x squared is 0. Those two things go away. I have a 4xh. I don't have any other terms up here with 4x or with an x and an h in it at the same time. So that's going to stay. So we'll write 4xh. 2h squared. I don't have any other h squared terms, and it has an h in it, so it doesn't have to go away. So that stays. I do have a minus x, and I have a plus x. Those two things go away. Subtract to be 0. I have a minus h. It's got h in it. Doesn't have to go away yet. So that's here. And then I have a 3 and a minus 3. Those two things go away. And then all that stuff is over h. So we took a huge mess and we made it a little bit smaller. We're going to simplify it even just a little bit more, and then we'll be done with this one. What you should see is you have an h in common of everything on top. So I can factor the h out of the top. And remember, when you factor, you're undoing the distributive property. So we should still have 3 terms left over. If I factor the h out of this first piece, right here, I would have 4x left over. If I factor an h out of this piece, I'm still going to have an h, but it's going to be a plus 2h. And if I factor the h out of that one, dividing negative h by h, I still have minus 1. And then you could check certainly by distributing, and it's all over h. So the reason for doing that is hopefully now you can see this h and this h divide away, cancel out. All that leaves me with is 4x plus 2h minus 1. That is the difference quotient. Now, I really wish I could explain to you all the really incredible uses this thing has, but for right now, we just need to be able to do the algebra. It is part of the college algebra curriculum, so we need to be able to do it. That's how you do a difference quotient. Some of them are going to be more challenging. Some of them will be less challenging. We will keep ours, hopefully, so that you don't have to do anything bigger than squaring something or foiling it. If you have to do a cube, that's a mess. But I'll try and keep it to nothing more than, at the most, squaring something. So you took this thing, which is the difference quotient, and we ended up with that. There you have it. That should be enough. You now have everything up to 2.2. That should finish it.